As we move towards the era of zero-defect production and Industry 4.0, it's essential that you explore as many failure modes early into the program phase. And one such failure mode is tribology, in conceptual phase and in engineering phase both. Within tribology is a friction, and it's far from a constant number. Rather, it's a function of different variables. And you could ask, what are those variables and how it affects friction? Friction is a function of 4 variables: contact pressure, temperature, sliding velocity, and plastic strain. With contact pressure, friction reduces due to flattening effect. This explains why friction can be highest in the binder region and then significantly drops in areas like the draw bead or in radius. Elevated temperature is significantly impacting the lubricant effectiveness. With rising temperature, the lubricant becomes less viscous, or in other words, thin and watery, rendering it ineffective. In my opinion, this perhaps must be given a lot of importance while planning for serial manufacturing. Tools like TriboForm is helping in analyzing this risk through robustness checks for serial production. The speed at which surfaces are sliding against each other is influencing friction. Identifying the optimum lubrication condition is crucial for establishing the sufficient friction condition. Why? The low lubrication results in splits, and the high lubrication results, on the other hand, in wrinkles. So it's finding that sweet spot in between. Higher plastic strain will lead to lower friction due to surface flattening, like contact pressure. For a holistic approach towards tribology, you also need to consider sheet properties, the lubrication, and the tool properties, which I cover in another video. Accurately simulating these combined tribological conditions rather than relying on a constant friction value is essential for achieving the results that would mirror the reality and production environments. In conclusion, I would say to achieve feasibility and robustness in sheet metal forming, it's imperative that one takes care of the entire tribology, which is to consider the properties of sheet, tool, and lubricant. Equally important is that one considers friction as a variable and not as a constant value. To find out more, you can contact me or reach out to your local AutoForm offices to see a demonstration of how AutoForm manages friction and tribology in simulation. Thank you.